Hi guys, today we're learning about symmetry, and specifically lines of symmetry and rotational symmetry, which are slightly different, but we're going to show you those now. Your learning intention is to describe lines of symmetry and rotational symmetry, and your success criteria is that you can show factors of rotational symmetry and lines of symmetry. Let's get started. Firstly, let's have a look at symmetry. Now, as we know, lines of symmetry are lines that are drawn through shapes that mean that the shapes, when they're folded together, don't have any overlap. So for example, this first triangle here has one line of symmetry, because if we draw a line up the middle from the base to the base and fold it in half, there are no overlaps. Now, it doesn't have a second line of symmetry because we can't draw a line of symmetry through here, because if we folded the shape down, it wouldn't work. However, this shape here has three lines of symmetry. As you can see, if we fold this shape this way and in half, there's one line of symmetry. However, we could fold the shape similarly this way in half and this way in half, and that would give us additional lines of symmetry. Our squares and our parallelograms have four lines of symmetry, as you can see here. So because you can fold them in half this way and this way, you can also fold them in half diagonally to give you lines of symmetry. Now, we've been doing lines of symmetry at school for a long time, but next up we're going to have a look at rotational symmetry, which is a little bit different. So rotational symmetry, to get rotational symmetry, we actually work in orders, and orders are the amount of times that when you rotate a shape that it looks the same. So let's start with our S. So our S on this side. Now, if we rotate our S, watch us rotate it around. As we rotate it around, we notice that when we get to halfway around, our symmetry is exactly the same. Now, that's one order, so it's rolled around once, but we haven't completely rotated our object 360 degrees. So at the moment, we've only done 180 degrees, which is half of our circle. We need to rotate it around, and that gets to our second order. So this S shape that we've got here is a two-order shape, because as we rotate it, one order comes around 180 degrees and it's exactly the same. See how there's no overlaps? But we've only gone once, so we go another 180 degrees to get it 360 to give us our second order. So that makes it a two-order shape. Let's have a look at a little shape on this side. Now, at the bottom, we've got that this is a three-order shape. So how many times do we think that we might overlap this shape when we rotate it 360 degrees? Well, let's have a look. Let's start. So we're rotating it around, watching to see an overlap, watching to see an overlap, watching to see an overlap. Whoop, there's one overlap. Now, we're not all the way around yet, though. We've only rotated 33.3 degrees. Let's continue to rotate around. Rotating again. Well, there's our second order, but we haven't done a full 360 degrees. Now we're going to rotate around and finish our rotations back to zero. So that's a three-order shape because it overlaps exactly perfectly in 360 degrees three times. Let's try it again. Let's watch again. So watch the top side. Rotating around once, twice, and three times. So that's a three-order shape. Girls and boys, what I want you to do is try this at home. Take some photos of some shapes around your house. I want you to see if you can find, does the shape have rotational symmetry? Now here's a clue. All shapes have at least one rotational symmetry. If you start at 360 degrees and go right around, it's always going to come back to being that shape. So they always have one order. But can you find some that have two or three orders? Have a look and see what you can do. I want you, if you can't find the orders, I want you to show the lines of symmetry on that shape. Remember, lines of symmetry mean that you can fold a shape exactly perfectly together. Today's learning intention was to describe lines of symmetry and rotational symmetry. And your success criteria is that you can show factors of rotational symmetry and lines of symmetry. And I'm sure once you upload them to Seesaw, you'll meet that success criteria. Give it a go, try it at home, upload it to Seesaw for your teachers to look at. Have a great day. Bye for now.